How can lines behave like points in projective geometry? Imagine a world where lines and points are more flexible than in the usual geometry you know. In this world, lines can act like points, and points can act like lines. It sounds strange, but it is exactly what happens in projective geometry. This branch of mathematics extends the normal ideas of shapes and lines by adding special points called points at infinity. These are places where parallel lines meet, which never happens in regular geometry. When you think about it, this makes the rules more balanced and consistent. In projective geometry, the idea of duality is very important. It means that statements about points and lines can be swapped around without changing their truth. For example, in normal geometry, two points determine a line. In projective geometry, the dual statement is that two lines determine a point where they meet. Because of this, lines can be viewed as points in a different space called the dual space. This is like looking at the same picture from a different angle, where lines become points and points become lines. To understand this better, picture a three-dimensional space where each line through the origin corresponds to a point in a special kind of space called projective space. Here, a line in the projective plane is like a plane passing through the origin in three-dimensional space. And a point in the projective plane is like a line passing through the origin. So, in this setup, a line in the plane can be thought of as a point in the dual space. When you write equations for lines in projective geometry, you use something called homogeneous coordinates. These are special numbers that describe both points and lines in a unified way. Each line can be represented by a linear equation, and each point by a set of coordinates. This makes it easier to see how lines and points are connected and how they can switch roles. This idea is especially helpful when graphing shapes and lines. It explains why parallel lines seem to meet at a point far away, called a vanishing point. This point at infinity makes the geometry look more complete and realistic, especially in perspective drawing and computer graphics. So, in summary, projective geometry adds points at infinity so all lines meet somewhere. It treats lines as points in a dual space, making the whole system more symmetric. Lines in this space are like planes through the origin in higher dimensions. This duality helps us understand intersections and parallel lines better, especially when drawing or working with advanced geometric systems. It turns what seems complicated into something more straightforward and consistent.